Hello and welcome to my lecture review for the textbook, Internet and Web Application Security, 3rd edition. This is done by Jones and Bartlett Learning. Again, copyright, they own everything. This is their book. I'm using their PowerPoints. I'm just providing video lectures for my courses that are using their official book. The assumption is you own the book and you are in one of my assigned courses. The book ISBN number 9781284206166. Again, copyright for the Internet and Web Application Security 3rd edition by Jones and Bartlett Learning is owned and maintained by them. These are just video lectures on their official PowerPoints, so let's jump on in. Chapter 6, Web Application Security. So, in this chapter, we are looking at identifying and mitigating web-related risks, threats, and vulnerabilities. The major concepts are understanding web app threats, vulnerabilities, website threats, vulnerabilities, and best practices for mitigating web attacks and weaknesses. So, web application. What are they? So, a website is a group of web pages interlinked under a common domain name, google.com, or Amazon, or whatever. They can be hosted on one or more servers and can be accessed over a network or the internet, typically through a single IP address and or domain name. Amazon.com, for example, we know it as Amazon, but in reality our equipment knows it as whatever IP address it is. The nice thing is, depending on where you're accessing Amazon from, you may actually be hitting more than a single server. So the big thing here is to understand that a website is a collection of web pages that are available. A web app or web application is a computer program executed through a web browser, typically from within a website or web page. It's used to perform functions such as a contact form or calculator, a playlist on a music store, Canvas, Google Docs, any of the Office 365s, Google Sheets, anything like that. This is typically also defined as a client-server program. The client, your web browser, is accessing the resource on a server. The application will supply the client-side support and the server-side processing. So these are just, again, a short lists of web apps. There are way more out there. It's just, this so that you understand what the difference between a website and a web app is. So let's go and look at some vulnerabilities. A vulnerability in a web app is basically a weakness in the system surrounding the web app, because the web app is just an application running on a server. So a flaw in the it could also be a flaw in the application itself. These are caused by misapplied settings, misconfigurations of either the web server, the data that's entered into a form, a database, some type of input structure, or data that's not been validated for the content or even the format or the design. Or it could even be programming errors. Security organizations have developed and maintained and published web app vulnerability. So we have the OWASP, we have the National Vulnerability Database, NVD, and we have the U.S. Computer Emergency Readiness Team, or U.S. CERT. These are the big three teams. It's not an exhaustive list. There are definitely more, but these are the typical go-to ones. So, application security areas. We have the internal security and we have the external security. Internal, the measures are applied within a local network to protect against local attacks. Again, that's going to be like on the LAN. Majority of the threats here for internal networks are, again, internal. Security measures include anti-malware, restricted access, restricting privileges, sometimes multi-factor, and then again, lots and lots of logging. Failures could affect the website's database, display content, and any other element stored on the web server. External security could be the security measures applied to all the computer systems throughout the organization or throughout the location of that web server. If it's in a DMZ or a data center, for example, goal there would be anything within that sphere needed to be equally as secure. Protects the entire network infrastructure from threats that search for and identify vulnerabilities or launch DOS attacks or malware or other types of malicious content, trojans, viruses, spyware, ransomware, and so forth. So these are a clear example between internal and external threats. These aren't the only types of security. We also have things like perimeter security, the electronic and digital protection and security measures protecting against the physical access. If I can walk into the room and steal your server, then it's not as secure as people think. Even though oftentimes this is definitely overlooked, physical and perimeter security are also just as critical as digital forms of security. A website is made up of the following main components. Not sure why this is a security area, but it is. You have your front end, that's the navigation, the page layout, the graphic design, things like that. You have the content, and then you have the back end, which provides the functionality. So those are the makeup of a website. Web services are the software that a web app can access directly and interact with over a network without any interaction directly with a user. Interaction between a web app and a web service is commonly facilitated through several open standards. XML or SOAP are two of the main ones. XML is a standard data markup language that is used by web apps to pass messages and tagged data regardless of the platform between a sender and receiver. SOAP is a simple object access protocol, which is an XML-based protocol used by applications to communicate over HTTP and access other web services. Interactions between a web app and a web service is commonly facilitated through, again, other areas as well. So you have the web service description language, WSDL, pronounced WSDL, which is an XML-based language that describes the services and functions available from the web service. You have to also have JSON, which is a JavaScript open notation, pronounced JSON, a standard format used to define data structures using a text-based format based on JavaScript syntax, used for transmitting data between a web service and a web app. You also have REST, representational state transfer. This will be using HTTP methods GET and POST to apply elements in a REST application using an API. Used commonly to identify URLs to other services. So let's look at this graphically. So we have our web services that kind of interconnect all the major components. The web servers, our word processing apps, our email apps, our file conversion apps, our file servers, the chat apps, and so forth. So that gives us a nice kind of understanding of the relationship between web apps and web services. So now let's look at common types of attacks. Organizations must have a clear understanding of the current threats that affect the network and web services. They also need to understand how the data moves through all of these services. Websites and web apps are targeted by hackers and cybercriminals on a regular basis. Attackers result in loss of data, identity theft, brand integrity, money, or just reputation, which is part of brand integrity, but that's a big one. Organizations must design and implement strategies to protect and mitigate the different vulnerabilities that are on their network. So we have Web Application Security Consortium. It's a nonprofit group dedicated to promoting the best practices of web app security. Oftentimes, you can find local chapters in big cities, and all they're gearing towards is security of web apps. And it's normally made up of professionals in that community. Participants are both experts and beginning students of web security or app security. Individual academic institutions, corporations from all around the world, anyone can actively participate in WATSEC. They help to identify an extensive list of threats to web apps and web app processes. That way, they know how to handle them. We actively discuss that we could figure out best path forward and have standard operating procedures, SOPs, to better protect our assets. Common website attacks. I'm not reading the entire list, but brute force, buffer overflow, formatting, attacks for XML, OS commands, URL redirect abuse, things like that. Abuse of functionality. Takes advantage of a feature of a website or web app to launch the attack. Oftentimes, you can use something that was implemented from a forum or a blog or a login page. It was implemented so that users could use it. But if it's not done correctly, it could then be used as a way to attack itself. A search bar, a search function. If you don't actually filter the input, maybe it could be used to do an SQL injection. Other things could be a brute force attack, attempts to crack any of the cryptography keys or passwords by guessing. Use lockout policies. Make sure there are standard practices that are implemented to prevent a lot of the potential damage. Buffer overflow attacks occur when applications move information stored in their buffer then to a space reserved for someone else. Content spoofing creates a fake website or web app to fool users into thinking it's a legitimate website. It can also be used for stealing login credentials, credit card data, and more. Credential or session prediction is basically an attack that involves impersonating a website user and then using the rights and the privileges of that user on the site. It basically tries to obtain a session ID from authorized users. We also have things like XSS, CSRF, and denial of service attacks. XSS obtains client browser cookies, security tokens, and other PII that can be used to identify the client within the website and the web server. Attackers can assume the identity of the client by impersonating the interaction with the site. Basically, if I am able to grab your session ID, and you're on like Amazon, for example, I could then pretend to be you and have that login information, or just have whatever information is there that I could be using as relevant. Basically, maybe you have a shopping cart, I steal your session ID, I can now see your shopping cart. That's a pretty common form of an attack, and one that's easy to check and verify. We have our CSRF. It's very similar to XSS. It creates a link that takes a visitor to a malicious uniform site and exploits a trust website has for the user's browser. We also have a denial of service attack that basically floods BS traffic to a device or server or an appliance so that you overwhelm the services of whatever service or whatever thing that you're targeting, so it starts acting weirdly and thus allows the attacker to get in or do something malicious, or it may just prevent legitimate users from actually accessing the resource. It really depends on the purpose. Other forms could be a physical realm, But we're not quite there yet. We could be looking at trying to determine the operating system using fingerprinting. This gathers information about the target system, including things like OS, web app versions, the database information, architecture, resources. Attackers use this information in other attacks, such as XSS and buffer overflow attacks. That way they kind of know what they're looking at and getting into. That way they can target a little easier. Format strings, basically similar to a buffer overflow attack, in that both attacks exploit the user input. The format string attack basically involves a user input interpreted as a command by the application, and is successful because the user input is not validated. Maybe I have a search bar and I say navigate to C drive. That's very simplistic, but that is a good example of the type of an attack that does actually occur. So it really just depends on what you're trying to accomplish. The big thing is, for security, you always want to validate user input. Alright, so moving on past that, we have things like our HTTP transfer documents. We already know that within our HTTP we get a request and response. And so HTTP works on that client-server model, with the client system requesting information from the resources that are stored on the server. Here's a example of that client response between the client and web server. Well, in the real world applications, the clients usually don't communicate directly with the web server. Rather, they communicate through intermediary points such as firewalls, proxies, and so forth. So here we have a more realistic example. We have a client going to a proxy, going to a firewall, then going to a web server. So why do we need to worry about this? Well, when we're talking about common types of an attack, well, understanding the actual data flow is actually kind of critical. So HTTP responses and requests, splitting attacks. That's a really common form of HTTP attack. The objective of these attacks is to split something. The split object is the header and the error message. The criteria are required for either of these attacks to be successful. A web app must be vulnerable to the attack, and the attacker must send specifically formatted HTTP-based messages. These request split attacks cause an application to return a response to what it interpreted as two responses. The response attack basically is similar, but the threat is used to have some type of unexpected carriage return. If successful, the attacker can interact directly with the web server instead of the application layer. We also have a request smuggling. In this process, it's basically effective when the web proxy or web app firewall are between a web server and the end user. It's common for a request for a web content to be split into requests for different parts of the web page. In this case, the user requests for content is received by a load balancer or some type of reverse proxy. These split requests are sent directly to or passed through different web servers, each of which responds with a portion of requested content. However, if the original request includes malicious commands or specific characters, it can cause sensitive information or sensitive data leak and can be used to launch more malicious-based attacks. Integer overflows. Basically, integer-related vulnerabilities typically arise when the app performs some type of math function. So, for example, computing an 8-bit integer is often used. So an 8-bit integer has the value between -128 to +127. The integer overflow attack pushes the integer beyond the boundary to, let's say, 128 or 129. Thus, an integer overflow then occurs. The result of the exceeding integer boundary can lead to undefined and unpredictable outcomes, crashes, and or other weird behavior. Additionally, integer overflows can result in a buffer overflow that can be used to execute malicious content. Moving past that, we have our injection-based attacks. These are classes of cyber attacks that include various attacks that essentially inject or insert code into the web app. In general, the inserted code is interpreted right along with the original code of the app. The injections are made to steal, destroy, modify, or create. Injection attacks are considered to be a major problem to more common websites. OWASP does list SQLi or SQL injection as number 1 in its top 10 threats. Other forms might be a LDAP injection. It allows websites to be exploited that allow LDAP statements from supplied inputs. Again, any type of an injection attack injects commands or injects code that the system just and then interprets as part of the regular process. We have our mail command injections, and that are attacking our mail protocols. We have a null byte injection, and that's a lower level program language that can cause just odd behavior. It basically is used to cause unknown behavior to the website and peripherals so that they can see what's going on, or could possibly crash a system. It really just depends. We also have a server-side injection. Occurs on the web server, not the client side. Malicious code is placed in a web app and stored on the server. When the web app is executed locally on the web server, malicious code carries out the function. Basically, let's say you want to upload an avatar. You upload an avatar that also has injection-based content. Then when the server actually calls your avatar, it executes all of the commands, including the malicious. That could be considered a server-side injection. We also have our traditional SQI, which will exploit SQL when it's not properly deployed, configured, or updated. A successful attack will allow the attacker to access, read, delete, modify anything within the database. And again, this is a pretty common attack, sadly, still. Other forms of attack could be things like a XPath attack. This is where attackers inject data into the application so that it executes in a user-controlled XML path. This will allow attackers to bypass authentication mechanisms and access XML information without proper authorization. We also have an XQuery injection, which is basically a more advanced SQL attack that will also hijack an SQL query. An XQuery injection attack does the same for a XQuery command. In both cases, the attacker attempts to send data that may be acceptable to search, but are malformed to interrupt the query. The end portion of the sent data will be malicious, sending a command or trying to elicit information. All are unauthorized to the attacker, but would be executed by the system with its own privileges on behalf of the attacker. So it's trying to get into an area that it doesn't have permission for so that it could then do something. We have a URL redirect abuse. Basically points a HTTP or a link to a URL or a web page to a different location or URL than a user has expected. It can redirect users to a malicious website. It can hijack a URL and then, or it can hijack a page and then, or embed even these redirection links. You also have an OS commanding. User input launches unauthorized commands to the operating system. Executed commands by an attacker will run with the same privilege as a component that is executed by the command. Database servers, web app servers, things like that. Attackers can gain access or damage parts that otherwise should be unreachable, like the operating system or its directory. Let's say that you are operating in a INET pub folder. That's where our web content is. Well, if you're actually able to gain access to the underlying operating system, you could then issue OS commands to navigate outside of that folder that you shouldn't actually have access to. That could also be known as a path transversal attack. That's where an attacker will attempt to circumvent file and directory areas to access files and directories where data is located elsewhere on the server. Predictable resource location. This will use a brute force attack to guess on default file locations to access unauthorized areas. We also have a remote file inclusion, RFI. Attackers place their code and input on a target system, commonly attempting to take advantage of a weakness in, let's say, PHP. If successful in ejecting files and code into a PHP-created website, they can then access anything on that site, such as databases, passwords, PII, and all of this allows for running of malware code on that target system. We have a routing detour. Also, this is funny because it's a man-in-the-middle attack or an on-path attack. So it really just depends on what book you're reading, but it's a man-in-the-middle. That's something that sits between the client and server that then has data flow through it so it can then do something malicious. We also have session fixation, and this is an impersonation attack that will refer to when an attacker attempts to use the session credentials of a valid user to gain access. A session is a communication between a system on a network and something else. The fixation attack allows the attacker to steal and use valid user details. The attack can be successful when an authenticated user session ID does not immediately expire, allowing an attacker to capture and then use that existing session ID for something else. Here is an example of a on-path attack or man-in-the-middle attack. Basically, it kind of goes between source and destination and funnels all of the information through the attacking system. Here's an example of a session fixation attack. Here we have a client that goes through and is working with a web server. It then gets details. The attacker might send a get login detail, a session ID, and a get command. The attacker might be sending something to the client system, like a web portal with a session ID. That way, the client, when it opens up that, might then open up the session ID to that web server that will then also forward a get login with that same session ID, but will prompt the client system with a user ID and password, which the client system would then enter, thus allowing the attacker to pull that information. We also have a SOAP array abuse. This is a general method for communicating with XML over the network. It's commonly used for browser access web apps and in communication occurring between the backend application component and a front end. SOAP communication can be exploited using a user injection code similar to an injection attack. It allows for XML syntax using characters such as arcarets and forward slashes that can be inserted into SOAP communication, allowing the attacker to interfere with the data message. Other forms of attack could also be XML attacks, and that is used for data that's exchanged between the web server and the client to store configuration data. If the parser or reader is misconfigured, it creates a vulnerability for any of the web apps. XML attribute blowup is a form of denial of service attack. We have external entities. Instead of reading XML output, applications return password files of the local web server. Again, a lot of this is just due to misconfiguration and a lack of verifying that your systems are current on updates and tested regularly. Other forms are XML entry expansion, again another form of XML attack, and then XML injection, which will take advantage of the trusting nature of XML applications. If this type of an attack is successful, it will follow garbage in, garbage out rule of data processing. If unintended or malicious content is fed into XML messages, the results will likely also be malicious. We also have common website weaknesses. And those are application misconfiguration, directory indexing, improper file system permissions, input handling, output handling, information leakage, unsecure indexing, and so forth. We're going to go through each one of these examples in the next several slides. Alright, so let's look through these. Application misconfiguration. Sadly, there's too many web apps that have vulnerabilities out of the box, additional features enabled by default, credentials that are left by default. Oftentimes, so many people leave the default configuration of most apps, thus not having it secure. Manage application misconfiguration through application hardening and checking and verifying. That's a big one. Directory indexing. Users enter a URL into a web browser. The page is retrieved and presented to the user. Automatic directory listing identifies all files within a given directory if the base file is not found. Automatic directory listing sent to the client system may contain directories or files never intended for them to actually be able to see them, but it does happen. Improper file system permission. Basically, you can give inappropriate access to files and folders to users because you didn't mean to, and you didn't check. Input handling. External user input is potential because you need them to interact with your website, so you give them like a search bar. You give them login pages. You need to be able to validate and sanitize input off of whatever input boxes you have, rejecting known bad input and only accepting what would be considered good input. Improper output handling occurs when sensitive data like logs or error messages are passed to another application unintentionally. Again, you want to make sure you can see what is leaking off of your website. Moving past that, we have things like information leakage. That's where a website or web app discloses sensitive data by accident. Strategies for reducing data leakage is basically check your equipment, check your systems. Are they updated? Verify that they're free from vulnerabilities. Do some hardening. Verify things like authorization, authentication, accounting is all there. And have some policies and procedures for testing and verification. Unsecure indexing. Basically, spiders and bots may collect sensitive data or unwanted information during web page indexing. Insufficient anti-automation. Anti-automation attacks occur when the process that should be manual or automated by an attacker, like an autofill form. How do we prevent this? CAPTCHA. Insufficient authentication. Basically, when a website prevents an attacker to access sensitive data or functionality without ever being properly authenticated. Insufficient authorization. Basically occurs when an app does not apply adequate controls or protections to ensure that authorization policies are used and then enforced. We have insufficient password recovery tools. So you can use a recovery system with a username and password or a forgot password section. That way, users can actually then reset their own user passwords. So if the password recovery procedure is insufficient, attackers may pose as a legitimate user and gain access to the password. There needs to be an actual process for verifying and checking and all that fun stuff. Insufficient process validation. It occurs when an attacker skips steps in a transaction or online process and generates errors or unforeseen results. Basically, if they can bypass and they can get weird things to happen, that's a win for them. Because weird things that can happen mean that not normal behavior is going to occur. Insufficient session expiration occurs when session trust between a device and network can be exploited by an attacker who captures the session ID and then can interpret or impersonate a valid user. insufficient protection, referring to failures to encrypt or secure communication at layer 2. And that means either TLS or SSL. Server misconfiguration. That's when the server may have too many of the default configurations or admin accidentally misconfigure the setting, thus allowing it to be targeted. How do we fix this? Hardening and customizing server settings for security and following best practices. Also check for basic vulnerabilities and again apply basic system hardening techniques. Best practices for mitigating web apps and weaknesses. Mitigate the attacks by implementing, again, best practices. Be security conscious. Know your infrastructure. Know the flow of data. Be proactive in making sure that things are kept up to date and you verify and you check for weaknesses and vulnerabilities and ensuring patching is regular. Mitigate weaknesses by, again, practice due diligence for mitigation of weaknesses. Be aware of vulnerabilities that are commonly in your environment, and then be proactive to prevent those vulnerabilities from ever being realized. Alright, that's the end of this chapter. We looked at web app threats, vulnerabilities, website threats and vulnerabilities, and we ended with best practices for mitigating web attacks and weaknesses. Thank you. Alright, that concludes this video lecture for this chapter. If there's any questions, thoughts, concerns, or issues, please don't hesitate. Feel free to reach out. Thank you.